There and welcome to this video on adding and subtracting polynomials. Please like and subscribe if you find this video helpful. Drop a comment or question below. Check out the other videos on the channel, and I'm going to link a card to a demo video on algebra tiles when we get to that spot in the lesson. So if you don't check out anything else, be sure you click on that and check that video out because that can add a whole new way of processing and visualizing what we're going to cover in this lesson. So we're going to start off with a definition of polynomial. And polynomial, I mention a lot, is one of those things that's fairly easy to work with, but difficult to define. So this is a pretty good functional definition. There's one piece of it that's missing, and I'm going to link in the description box to a video that will explain the piece that's missing. But a polynomial could be defined as an expression whose terms take the form ax to the n, where a is a real number and n is a non-negative integer. So for example, you might see like a real number here, like say 3, and then x, and then whatever that exponent is, it has to be non-negative, so we're not going to see anything negative, and it has to be an integer, okay? So it might be, say, the number 4. Okay, but you can't have 3x to the 1/2. Okay, that is not an integer. And 3x to the -2. Okay, that also does not work. Now you could see, say, -2x to the 4th, because a just has to be a real number. So the a value, the number that's out in front, that can be negative, that can be a decimal or a fraction, but not the exponent. And essentially, to make a polynomial, you would take a whole bunch of terms that look like this and then add them together. Okay, so you might have -2x to the 4th plus 1x to the 3rd minus 4x squared, and so forth. Okay, so you just take a whole bunch of things that look like that and you would add them together. Now, there's a lot of different ways that polynomials are classified. So under the umbrella of polynomial, we have all these other vocabulary words that we use, and we do use them. Now, some more than others. So we're going to look at some of the ways that polynomials are classified here. First of all, you could have what's called a constant polynomial. And this is the piece of the definition that, if you've been following along with these videos, might be missing. But for example, the number 4, okay, that is a polynomial. It's a constant polynomial. And you're probably thinking, that doesn't work because you just said that it had to take the form ax to the n, and there is no x there. Here's what's there. So if you just saw a 4, okay, and this is something you kind of have to take from my word for it right now, it's x to the 0. And remember that exponent had to be non-negative. 0 is not negative. So if it were 0, that ends up being equivalent to 1, and then 4 times 1 is just 4. And we don't typically write the x to the 0. Now, sometimes with my own students, I'll say, well, we haven't covered that yet, so for now, I need you to take my word for it. But what I'm going to do is I'm going to link in the description box to a short video, okay, like a short video that explains why that is equal to a 4. Okay, so if it bothers you, you're like, I don't trust strangers on the internet that just make math videos for making math videos. I want to see why that is equal to 4. Click on that, just go pause the video, go click on that link, and then come back to this one so that you can feel better about it. So we have constant. We could have a linear polynomial, and a linear polynomial, this is good news for those of you that have been following along with this. This would be something like 4x minus 3, and you can tell that's linear because it fits the mold of y equals mx plus b. It's just the mx plus b part of it. So 4x minus 3 would be a linear polynomial. So everything that you've been studying in your Algebra 1 journey up until this point has been a polynomial. All that stuff with lines, like graphing lines and solving linear equations, it falls under that bigger umbrella of graphing polynomials and solving polynomial equations. We don't usually start with the word polynomial because it's kind of an intimidating word, but you have been working with polynomials. You've just been working with linear polynomials. We also have quadratic. Okay, so a quadratic polynomial, we've introduced this. This might be 2x squared minus 3x plus 1. Okay, and you know that is quadratic because of the x squared. Okay, that gets into like what is a quadratic, but it is an x squared because or a quadratic because of the x squared, and so forth. And it actually goes past that. So if you have an exponent of 3, it's called a cubic polynomial, and then after cubic comes quartic. That means you have an exponent of 4, and then a quintic. And but reality is we don't use those words a whole lot. We do use cubic. Okay, so cubic would be that next one up. So a cubic polynomial might be x to the third minus 2x squared plus 4x plus 5. I'm just making some stuff up. Okay, and then past that, we don't usually use those words. So it can be classified based off of whatever the highest exponent is. If the highest exponent is a 0, it's a constant. If the highest exponent is a 1, so just in case you don't remember, that would be x to the first power. It would be linear. If the highest exponent is a 2, we call it a quadratic. If the highest exponent is 3, it's called a cubic. Then they can be classified based off how many terms they have. So for example, a monomial has just one term. And if you think of the prefix mono means one, like the Disney monorail has one rail. So this would be an example of a monomial, just a 5x. Okay, so there's only one term there. After a monomial comes a binomial, and the prefix bi means 2. So a binomial has 2 terms. So that might be something like 5x plus 3. Okay, that would be a binomial. Or it could be like x squared minus 1. That would be a binomial. So as long as it's just 2 terms there. And then after bi comes tri. That has 3 terms to it, and that might be something like 3x squared minus 2x plus 4. Okay, and that would be a trinomial because it has 1, 2, 3 terms. So that's a lot of vocabulary that I just kind of dumped on you on this slide. If you want to pause the video and grab a notebook and just write it down, writing it down will help you remember what all these vocabulary words are so that when I'm using them or when your teacher is using them, you know what we're talking about. But these are all fairly common. You will see binomial and trinomial a lot, and you'll see like linear and quadratic a lot. So those 4 words. We don't say monomial too much. It does come up. I won't say you'll never see it, but it's not a really common one. And the same with cubic. Cubic is fairly common. You will see it, but it's not the most common thing that you would see. Okay, so how do we add and subtract polynomials? So that's the title of this lesson. So now that we've kind of covered what polynomials are, how do we add or subtract them? And you might be wondering, we're 8 minutes into this video and you haven't even got to the topic. And you're not too worried about it because this is usually very straightforward. So all we do is combine like terms. That's literally all we do when we add and subtract polynomials. What does that mean? It means that you combine constants with other constants. So if you saw one constant like a 2 and a 5, you would combine those together to get a 7. You combine x terms with other x terms. So if you have a negative 3x plus 5x, you would combine those together to get 2x. Combine quartic terms with other quartic terms. So x squared plus x squared would give me 2x squared, and etc. So on and so forth. So if you had cubic terms, so pretty much what you have is you have these 2 polynomials and you want to add them. You're just going to look for all the matching parts and add the matching parts. If you were subtracting them, you would do the same thing, except you would subtract all the matching parts. Like that's pretty much all there is to it. So we're going to look at a couple of examples. So you'll notice this one, I've got the same example written twice, and that's just because I'm going to show you two different ways that you can structure it. So this is a horizontal. This is how I was taught to do it. And if you notice, we've got these parentheses, and the parentheses are blocking off the polynomials. So the first polynomial is 2x squared minus 3x plus 4. The second polynomial is x squared plus 5x minus 6. What I tell my students is that these parentheses are cosmetic. And that's a good word there. It's even better. It's even better word if you spell it right. Cosmetic. And I asked them, what are cosmetics? Give me an example of cosmetics. And they'll say, well, cosmetics is makeup. If you go to a department store or something, or go to the cosmetics counter, they're going to sell you makeup. And the thing about makeup is that makeup will change how something looks, but not how it works. And so if you put on a lot of like eyeliner or eyeshadow or something, mascara, you can change the appearance of your eyes, but your eyes are still going to work the same way. That's what I mean when I talk about cosmetic parentheses. These parentheses are setting the two polynomials apart, but they're not performing an algebraic function. It's a visual function so that you are able to look and say, here is the first polynomial, here is the second polynomial. But in terms of actually adding them together, it doesn't matter whether the parentheses are there or not. We're just going to look at the like terms. And so you can just remove the parentheses. Now, to combine the like terms, this is what we do. We have 2x squared plus 1x squared. And remember that that is a 1x squared. Well, 2x squared plus 1x squared gives me 3x squared. Negative 3x plus 5x, well, negative 3 plus 5 is 2, so negative 3x plus 5x is 2x. And then last but not least, we have 4 minus 6, or if it helps you out, you could say 4 plus negative 6, and that would give me negative 2. So you could write that as minus 2 or plus negative 2. And that's really all there is to adding polynomials, is you're just going to go hunt down where are those like terms, the things that are the same, and add them together. Now, over on the right here, I just want to show you another way of setting that up. Some teachers, okay, do like to set this up vertically, where they'll stack the like terms over each other and then add going down. So 4 plus negative 6 is negative 2, negative 3x plus 5x is 2x, and 2x squared plus x squared is 3x squared. There are advantages and disadvantages to both of those structures, okay? Whatever your teacher does or whatever you're more comfortable with. Okay, you can set it up horizontally or vertically, and I just wanted to show that to you. It's about the same amount of work involved with each of them, so just kind of pick whichever one you like better. Now, subtracting can be a little bit trickier because in this case, the parentheses are not cosmetic because of the minus sign. The minus sign is an operator, and the operation is happening to the group, okay? So it's not just the 4x to the third that's being subtracted, it's everything in those parentheses. Now, what might help you out is to remember that subtraction literally means to add the opposite. Okay, and remember, when it comes to opposite, the opposite of 3 is negative 3. The opposite of like negative 4 is positive 4. So when you are subtracting, you might want to picture it like this. Okay, this is instructional. You would not typically write this out. It's plus the opposite of. And then what are you taking the opposite of? Every single thing that is in that parentheses. Now, this first set of parentheses can drop. These are cosmetic, okay? That first set of parentheses is, you can take it or leave it. It's the second one that has the issue because of the operator in front of it. So I'm just going to go ahead and remove those parentheses. So I have negative 2x to the third plus x squared plus 3x minus 7. And now I'm going to add the opposite of all of that stuff. So the opposite of 4x to the third is negative 4x to the third. The opposite of 3x squared would be negative 3x squared. This one, be careful, this is a negative 4x, so you might want to remember subtraction is always to add the opposite. And so this would be the opposite of negative 4. Well, the opposite of negative 4 is positive 4, and it's 4x. And then we have the opposite of 1, which is negative 1. And now the problem is exactly the same as it was before. Okay, it's just like an adding problem. You're just going to combine the things that are the same. So we've got negative 2x to the third plus negative 4x to the third. So that would be negative 6x to the third. We've got positive x squared plus negative 3x squared. So 1 plus negative 3 is negative 2. So you can write plus negative 2 or minus 2x squared. 3x plus 4x will give me 7x's. And last but not least, negative 7 plus negative 1 is negative 8. And at any point in there, you can use a plus, a minus sign, or a plus, a negative. Okay, just whatever is going to make more sense to you. So super common mistake, and I'll mention this a little bit later in the video, is not distributing that negative. So that subtraction does go with everything in that second set of parentheses. So you've got to make sure you flip the sign for everything. Now, just a quick example with what are called missing terms. And I put missing here in quotation marks because there's nothing about a polynomial that says that it has to have all of the terms in it. You can not have some. So if you look at this first one, we have x to the third, but we don't have any x squareds. Okay, and then we have an x, and then we have a constant. And so you might not see an x squared. Now, what it means is that it's 0x squared. Okay, that's what it means. So if you're going to use that vertical method, that's what you would put in there. But I'm not a huge fan of the vertical method. I was taught horizontally. Now, remember, this subtraction means we're going to add the opposite. The opposite of 3x squared is negative 3x squared. The opposite of 2x is negative 2x, and the opposite of 5 is negative 5. And now when we combine them, you'll notice that there is nothing for the x cubed to combine with. So the x cubed comes down. There is nothing for the negative 3x squared to combine with. And so we'll just bring those down. Now here we've got positive 2x minus 2x. Well, that's going to give me 0x. And then we have negative 1 minus 5, or negative 1 plus negative 5, which would be negative 6. And normally we would not write that 0x. Okay, so that would be a weird kind of move, because 0x is just 0. And so I wanted to make sure that I at least did one where you were missing some of the terms, where some of the terms aren't showing up. Okay, now this is where hopefully on the upper right hand side of your screen somewhere you will see a card. If you don't see it right now, it'll pop up in another couple seconds before I'm off of this slide. Now, algebra tiles are a visual way to use geometry to conceptualize this and to make it hands-on. So you can actually get a set of these tiles and make your polynomial something tactile. And the way they work, they only work up to quadratics. So you can't use algebra tiles for cubics or x to the fourth. Good news is that most of what you do is going to be quadratics. And what they do is they use area. And so if you were to picture a square, and the side length of the square measured x. Well, in a square, all the sides are the same. And so this would be x times x. The area inside would be x squared, or x times x. And so you would have little tiles, like these squares, that represent all your x squares. Your x would look something like this, and it would have the same height as the big square over here. Okay, so that X would match up with that X. But in this case, the width of the tile is 1. And so the area would be X times 1 or just X. And then now you've got these rectangular tiles that represent an X. And then your ones would be something that look like this. It would be 1 by 1, and the area of a 1 by 1 square is just 1. And this one matches up with this one here. So you could, in theory, stack them, and like the different edges would match up. So you'd have X, 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 1, 1, 1, and they would all match up. And they can also do negatives. So typically, if the algebra tile is one color, it's positive, but if it's red, okay, so if it's yellow or blue or green, it's positive. And if you flip it over, it'll represent negative X or negative X squared or a negative number. All right, a couple common mistakes that happen when adding or subtracting polynomials. One is not subtracting everything. I mentioned that earlier. You do want to distribute the subtraction across all the terms in the polynomial being subtracted. It's always and only the one that is being subtracted, not what it is being subtracted from. And just not noticing if the terms are out of order. So typically in a polynomial, you'll start with the biggest exponent and you will count down. And so you'll go all the way down to, remember that was X is equal to 0. But there's nothing that says it has to be that way all the time. And so you might get a polynomial that looks like this, where they are out of order, and you just want to be really mindful of that when you're looking for your like terms, that they might not be in the position where you expect them to be. So just be a little bit mindful of that. All right, please don't forget to give this video a thumbs up if it was helpful. Subscribe to the channel for more math help. Drop a comment or question below, and check out the other playlists we have on the channel, as well as that algebra tiles video that I linked to, and the explanation for why x to the 0 is equal to 1. Also check out the practice set, and I will see you in the next one.